Now let's see what is meant by dynamic allocation, right? See, let us assume we have three processes, say P1, P2 and P3. Now coming to dynamic allocation, we will assign priority to every process. For example, let us assume we have assigned priority number 1 to P1, 2 to P2 and 3 to P3. And let us assume that the process which has the higher priority number has the highest priority. Okay, it is just an assumption. We can also take in such a way that the process with the least priority number has the highest priority. We have seen in priority based scheduling, right? It is exactly like that. Let us assume that here process with the higher priority number has the highest priority. By going by that rule, process P3 has higher priority than P2 and P2 has higher priority than P1, right? Fine. So what we have done is, let us assume we are assuming that we have three processes and we have assigned priority to every process. In dynamic, we are seeing dynamic allocation, right? Fine. Now what we will initially do is, whichever process which comes into the RAM, we will give only one frame. For example, we will give one frame to P1, one frame to P2 and one frame to P3, right? We are giving one frame to every process. Now in case if process P3 needs one more frame, see, right now we are executing all the three processes, right? We have given one process to every process and then we are executing these processes. Now during execution, in case, let us assume process P3 needs one more frame, right, in order to execute. Now what we will do is, we will check the RAM whether we have extra frames or not, which means we have frames which are free at this point of time or not. In case if we have extra frames, we will allocate one more frame to process P3, right? In case if we have extra frame. In case if we don't have extra frame, what we will do is, we will take this frame. See, we will not take this frame because the least priority is P1, right? P1 has the least priority. So what we will do is, we will take this process's frame and then we will allocate to process P3, right? Why are we doing this? Because process P3 has higher priority than process P2 and P1, right? So P3 should be completed before process P1 or P2, right? So that is what we have done. In order to complete execution of process P3, we might need more than one frame in the RAM, right? Which means we might have to have two pages of process P3 at the same time in the RAM in order to execute P3. Else it will lead to thrashing, right? We have seen what is meant by thrashing. Now if that is the case, we need to allocate two frames to P3, but unfortunately we don't have free frames of process P3. See, let us assume we have allocated one frame to P3 and one frame to P2, right? Now let us assume process during execution, we have come to know that process P3 needs one more frame. Now let us again assume that we don't have any free frame in the RAM at this point of time. Now what we will do is, we will forcefully take this process's frame and then allocate it to this process, because P3 has higher priority than process P1, right? In such a way, we will continue. Now P1 cannot proceed, right? Because P1 doesn't have any frame. So P1 cannot proceed. So P1 will be stopped. P1 will not continue its execution. Now, but process P3 can continue its execution. Why? Because process P3 has got two frames and it can execute now. Now in case, let us assume process P3 needs one more frame, right? Now what we will do is, we will again search in the RAM whether do we have any extra frame. In case if we have, we will take that and give it to P3. In case, since let us assume that we don't have any free frame at this point of time. So what we will do is, we will take this process's frame and then we will allocate it to P3, because priority of process P3 is higher than P2. So we will continue execution of P3. Again now P1 and P2 cannot continue because they don't have any frames allocated to them. Now P3 will complete its execution. Let us assume the three frames are sufficient to execute process P3. Now in case after execution, process P3's three frames will be relieved. Why? We have already seen in RAM, right? In case if a process has completed its execution, the process will be removed from the RAM. Okay, the process or the process control block, all the contents of that process will be completely removed from the RAM after completion, right? We have seen in part 1 course. So that is what we will do. Once process P3 has completed its execution, these three frames will be relieved from process P3. These three frames which are allocated to P3 will be freed, right? because P3 has completed its execution. Fine. Now what we will do is we will allocate it to process P2. We will allocate one frame to P2, one frame to P1, and then these processes will again continue its execution. Now in case if P2 needs more frames, what it will do is again it will search in the RAM. In case if we cannot get it, it will take this processes frame we will give this processes frame to P2. Why? Because P2 has higher priority than P1. So effectively what we are doing here is we are going to start every process with one frame. We are going to allocate one frame to every process and then we are going to continue the execution. Now in case if a higher priority process needs more frames, we will search in the RAM for free frames. In case if we are able to get it, which means in case if we are able to get at least one frame in the RAM which is free, we will give it to that process. Fine. Now in case if we don't have any free frames in the RAM, which means we don't have any frame which is not allocated to any process, what we will do is we will take the frame of lower priority process and then we will give it to higher priority process because we wanted to complete higher priority process. Now once higher priority processes complete their execution, those processes will be completely removed from the RAM. And then what will happen once higher priority process has been removed from the RAM? Our RAM's frames will become free, right? Now what we will do is we will allocate those free frames to lower priority process and then we will continue the execution. This is how, see, one thing you can understand from this is the number of frames allocated to a particular process is actually changing, right, depending on the situation. But this was not the case coming to static allocation. In equal allocation, we have initially made up our mind that how many ever frames a particular process need, it doesn't matter. I'm going to divide all the free frames among all the available processes, right? We are not going to change during execution. The same is what even happening with this technique. But coming to dynamic allocation, depending on the situation, the number of frames allocated to a particular process is actually changing during execution, right? So this is definitely a better method because it is changing depending on situation. That's what we mean by dynamic, right? So dynamic allocation is a better technique than these two techniques. Now, one question you might ask is this the best method? Dynamic allocation is always better than these methods? No, right? Because this is just a prediction. It might so happen that this can be a better method than this in some scenarios. But it is estimated that it is predicted that most of the times we will get better results with the dynamic allocation compared to these two techniques. Okay, so I think you understood the concept. What we are going to do here is we are going to complete higher priority processes as faster as possible, and then we are going to free that space so that after that lower priority processes can be completed execution. Now here we will not unnecessarily see, the main idea behind this technique is we are not actually allocating any extra frame to a particular process, right? Because every process is being allocated only one frame initially. Now only in case if a process needs more than one frame, we are giving the extra frame to the process, right? Now in case if a process doesn't need extra frame, we are not going to allocate it. But that was not the case coming to static allocation. We have decided, without looking into the process, we have decided how many frames should be allocated to a process and then we are simply assigning to them. But here we are not doing that. We are going to start with one frame for every process, and depending on the requirement, a process number of frames to a process might expand as well as it can shrink depending on the situation, right? That is what we mean by dynamic allocation. Again, it is a better technique. Okay, we still have more techniques, but these are the most common techniques which is given in most of the textbooks. Okay, fine.